Very good evening. Welcome to day 6 of short course program on metrology and mechanical measurements. Today's session focuses on an essential topic in engineering design and manufacturing: tolerances, limits, and fits. So, generally in precision engineering, it is impossible to manufacture every component to an absolutely exact dimension. Therefore, controlled variations in dimensions must be specified. This is where tolerance, limits, and fits become extremely important. These are our session agenda, what we are going to learn in day 6 segment. Let us now start with the basic fundamentals on tolerance and limits. First, let us go with basic size. What is meant by the term exactly basic size? The basic size is the size from which the limits of your dimensions are being derived by applying upper and lower deviations. Tolerance represents the permissible variation in the size of the component. It is the difference between the upper limit and lower limit. The upper limit is the maximum permissible size, where the lower limit is the minimum permissible size. The zero line represents the basic size from which the deviations are being measured. The fundamental relationship is tolerance can be defined by a simple empirical formula: tolerance equal to upper limit minus lower limit. Now let us understand the concept of fit. A fit represents the degree of tightness or closeness between the two mating components, usually a hole or a shaft. There are three principal types of fits as listed below: clearance fit, transition fit, and interference fit. In a clearance fit, the shaft is always smaller than compared to the hole. Therefore, positive clearance always exists, allowing relative movement between the components. Typical applications include sliding components and plain bearings. Transition fit: here the tolerance zones of the hole and shaft overlap depending on the actual dimensions produced. The assembly may have either a smaller clearance or a smaller interference. Transition fits are useful when accurate positioning is required. In an interference fit, the shaft is always larger than the hole. Assembly requires force or, in some cases, thermal expansion and contraction. This type of fit provides a rigid and permanent or semi-permanent joint. Next, we shall move to hole basis and shaft basis systems. In the hole basis system, the hole size is kept constant and the shaft size is varied to obtain the required type of fit. The hole is designated using a capital letter H. Say for an example, H7/G6, H7/K6, and H7/P6. The hole basis system is widely preferred in industry because it reduces the variety of reamers, gauges, and other precision tools required. In the shaft basis system, the shaft size is kept constant and the hole size is varied. The shaft is designated using the lowercase letter h. Example include G7/H6, J7/H6, and M7/H6. This system can be more useful when standard drawn shaft or bar stock is readily available. Now let us learn how to read a fit designation. Consider the designation: diameter 50, H7/G6. The value 50 represents the basic or nominal size of the shaft diameter in millimeter. The capital letter H represents the whole deviation, while 7 represent its tolerance grade. Lowercase letter g represents the sharp deviation, while 6 represents its tolerance grade. Remember, the capital letter represents the whole and the lowercase letter represents the sharp. Let us now consider a practical example. Suppose the hole size varies from 50 millimeter to 50.025 millimeter and the shaft size varies from 49.975 to 49.991 millimeter. So for this problem, we have to determine the correct exact fit required. To find out the clearance between the hole and the shaft. First, we have to examine which type of fit is needed and how much clearance between the hole and the shaft, so that we have to determine. The maximum clearance is calculated as the maximum hole size minus the minimum shaft size. Here in this problem, the maximum hole size is 50.025 and the maximum shaft size is 49.975. So that gives the difference of 0.050 mm. The minimum clearance is the minimum hole size minus the maximum shaft size. So 50 minus 49.991. So that will give you the clearance of 0.009 millimeter. Since both the values here are positive, so clearance fit always used for this type of assembly joint. So here the clearance range from 0.009 to 0.050 mm. So this type of calculation is very important for understanding how actual manufacturing variations influence the final assembly. Now, why tolerances and fits are so important in engineering design? First, they provide interchangeability. Standard fits allow mass-produced components to be assembled without individual fitting or selective matching. Second, the correct fit ensures functional performance. Components can rotate, slide, or remain rigid according to the design requirement. The third, appropriate tolerance selection improves manufacturability and cost effectiveness. Fourth, tolerances support effective quality control through inspection methods such as go and no-go limit gauges. Finally, proper fit selection contributes to reliability, service life, and maintenance. Correct clearance can prevent seizure, while suitable interference can provide the rigid mating surface. Let us now recap the day 6 key points. A tolerance is the permissible variation in the size, while limits define maximum and minimum permitted dimensions. The three principal classes of fits are clearance, transition, and interference. Hole basis system maintain a constant hole and varies the shaft. Shaft basis system maintains a constant shaft and varies the size of the hole. Regarding fit designations, for a quick reference, so we have just communicated the base size, deviation, and tolerance grade of the mating components for both hole and shaft basis system. Most important thing, the correct selection of tolerance and fits directly influences interchangeability, functional performance, manufacturing cost, quality, and product reliability. So therefore, this concludes the day 6 topic, tolerance, limits, and fits. Thank you for participating in this session, and I look forward to seeing you in the next day 7 session. Thank you all.